We'll hopefully have a recording of the meetup. Nothing, it doesn't depend on anything. Right. So my name is Andy. I work with Kamesh. Kamesh is typically the greeter, meter, host, organizer of Bessie's out on travel. Couple of little announcements. One is Arista and Chris will get a ball rolling in a second. So we're still working out on our next year's schedule. If you, so that'll be announced soon. I guess that's about it. Chris, I'll let you out. So there's a couple of more detailed things that I want to kind of told you guys, but probably we'll do it afterwards. Things like, do we want a more technical meetup, kind of before, after, during? The thought was that we will have hands-on coding, see how many people are. I'm said I'll do it later. I'm letting you think about it, and then we can come back to it at the end. If you have folks that work for you that want to get more hands-on, or folks that are here and are more coders, though I don't see the typical coders that I know. Yeah, the Red Hat guys, the Microsoft guy. I'm hoping it's not because of the venue change. So think about that. Without further ado.
Thank you. Thanks, Andy. And thank you, Kamesh, for giving us the opportunity. I've been a member of the OpenstackBoston meetup group since the summer. I'm Chris Campbell. I'm with Arista Networks. Now, before tonight and before the pizza, how many of you have heard of Arista Networks? Wow, a lot of people. That's fantastic. And thank you for coming to hear tonight's talk with our speaker, Peter Sprigata, on SDN, hyper-reality, and OpenStack and software-defined networks. So we'll tackle that, and Peter will get right into it. Before we do, I'd like to introduce some of the other Arista people who are here, who are based here in New England. I'm Chris Campbell. I'm the sales manager in the Boston area. We have our director, Chris Bellmare, who's front and center here, who covers the Northeast and Canada. Our system engineer, who's local, is Jim Maxwell. Our channel director is Jim Lord, who's right here. And Peter Sprigata will be the main speaker tonight. And certainly, as we go through the presentation, we're going to keep it interactive. My past couple meetups with this group, it's great when people start asking questions and there's just more of an informal dialogue, and that's where the learning comes in. We really want to have that begin as soon as possible. Just a little bit about who we are, who Arista is. Still a privately held company, pre-IPO. Been around since 2004, if you can believe that. The development of the extensible operating system, Arista EOS, was the cornerstone of the company and the initial innovation behind Arista. And then the hardware designs followed. Most folks, when they first hear about Arista Networks, it's, oh yeah, that's a 10 gig switch company. Well, there's 10, 100, 10 gig, 40 gig, 100 gig. We have top-of-rack switch. We have chassis switch for leaf spine data center designs, for applications in virtualization, big data, low latency, you name it. So anything to do with the data center, cloud computing, and data center networks is what we're focused on. We're not going to make this a sales pitch about Arista. I just wanted to give you a level set in terms of who the company is and where we're focused. And we're here to talk about OpenStack, its applications, automation within the cloud, and so forth. Software has to run on some hardware. And so instead of thinking of us as a 10 gig switch company, as most people initially think of us as, think of us as an open, extensible Linux platform. That's the philosophy behind Arista, is that the operating system is open, you have access to it, it's completely standards-based, runs on an unmodified Linux kernel. It's a Linux system. It just happens to be in the network. It just happens to do network control plane and wire speed routing at those speeds. So with CPU, memory, persistent storage and flash or optional onboard SSDs, optional FPGA capabilities that are all open to our customers and partners and the ecosystem around data center and cloud. It's really a platform for the next generation, and it's a Linux box. So we're going to provide the hardware for applications based in Python or RPMs or anything like that you want to run on the switch that can relate to your applications as you roll them out. And what we're talking about tonight is OpenStack. So I'm going to introduce Peter Spragata from our RTP area, who covers a lot of our service provider accounts, and he has a unique role within Arista. I'll let him explain that to you and let him begin the talk. So thanks very much. Thanks again for coming.
Great, thanks. And thanks to all of you for having me here tonight. Sorry, let me put this away because I will tend to play with that all night long if I don't. Gosh, where to start? I guess let me start with a little bit about me first. Yeah, again, my name is Peter Spragata. Here, I work here. You can hit me here. You can also find me on LinkedIn. Feel free to hit me that way as well. I've been doing this for about 19 years. I go actually all the way back to my very first gig was actually programming Fortran 77 applications on IBM mainframes. So, that was back in the days when the mainframe was the data center, or the data center was the mainframe, depending on, really how you want to look at it. So, I was young, I was fooled by money and decided, I'm going to leave the software engineering stuff behind and go do the networking thing and go make money. And I'm still waiting to make my millions, but hey, what are you going to do? But I've maintained a lot of that background with me over the years. And as I've moved around from different networking companies and helped customers to build their infrastructures, I've continued to be involved in open source communities. And most recently, I've been involved with OpenStack. I've been with OpenStack or been playing around with OpenStack for 14, 15, 16 months now, I guess, is about where I've been at. Mostly just doing bug fixes, patches, whatnot, and specifically around the compute infrastructure around Nova, and obviously now into Quantum. So that's kind of a little bit about my background and whatnot. In the daytime for Arista, I work with mostly service provider customers, helping them figure out how to take all these pieces together and build a lot of their infrastructure for their public cloud offering. I also work with some large enterprises and whatnot, but it's really focused on not so much how to build OpenStack, but as much as how to take OpenStack and build it into the framework of a data center architecture. And so I want to spend some time today talking a little bit about software-defined networking and what I've seen over the last year or so, working with these customers, working with some of the side projects I'm doing, and so on and so forth. But before I kind of get into this, a couple of things I'll ask. One, can you hear me? I want to make sure everyone can hear me. Good. Two, I want to make this very interactive. So please feel free to interrupt me, ask your questions. It makes me feel like I'm at home with my wife. So please, don't hesitate to interrupt. If we go off on a tangent, great. I'm more than willing to go off on any tangents. I'm not a guy that likes to go through slide after slide after slide. God, I did that for Cisco for 5 years, and I don't ever want to do that again. But I will if no one asks questions, and we'll all be bored, and we'll all walk out of here grumbling. That's the way it goes. So, with that being said, with no further ado, let's kind of jump into it. So I want to start with a definition of software-defined networking, because it's amazing, when you ask anybody, define SDN for me, you'll get a different answer from everybody, right? And a lot of it is based on context, where they're coming from, right? The compute guys have an answer, the storage guys have an answer, I guarantee you the networking guys have an answer. And in no way, shape, or form do those answers kind of jive or mesh or whatnot. So I'm going to try and define that a little bit. I'm going to start with saying, software-defined networking is a new way to build switches that effectively extract the control plane off of them. So you get a great big TCAM that can just forward packets, and we'll figure out how to do that by some other means. Well, that's not exactly how I would define SDN, although I would define OpenFlow that way. APIs, it's got to be about the APIs, right? APIs. Everyone's doing APIs. Okay, what do you want to do with those APIs, right? This is probably one of the fundamental issues that we're seeing right now with trying to get more organized in the OpenStack community. What do you want to do with this thing? What do you want these APIs to do? So along comes this application, network virtualization. Ah, now we're getting somewhere. Now we've got something that's starting to make sense, right? Network virtualization is really the first application that I see around software-defined networking. And hopefully by the end of today, you will too. So this is like mandatory for anyone who gives presentations, I think, is go to Wikipedia, find your term, and put a definition up. So I had to do this. I'm not sure if I would agree with the definition, but I think it gives us a point of reference. The big thing here, and what I really kind of take away from this though, is a couple of things. One, that we're talking about an architecture with SDN that no longer conforms to the standard networking protocols, right? We've built very large networks in the past, and we've done it with things like BGP and OSPF and spanning tree, and all the network engineers thought they were really cool guys, and they hung out, all by the water cooler by themselves and never really interacted with anyone because you couldn't speak our language. Along comes data center stuff, and the need to build massively scalable data centers. And all of a sudden, all the guys writing the software and all the guys building the computer infrastructure were saying, you know what, network guys, I'm tired of playing with you, right? I'm tired of going to beg you for another VLAN because I need to build my infrastructure that way. I'm just going to do it myself. And along comes a lot of what we were seeing around the idea of network virtualization, right? Just give me a pipe, I'll take care of the rest. I'm tired of messing around with you. And so, I think that's the one thing I take away from this particular definition is that it's really about programmable centralized control. But there's some caveats with centralized control. And we'll get into those a little bit later. First and foremost, what is SDN not? And I hope we can all come to this agreement. First thing it's not, thank you, Ivan. If you don't know Ivan, Ivan's a great guy. He's over in the Netherlands. He writes this blog called IP Space. I've met him a couple of times. He's a very interesting character. He's got great webinars. If you ever get a chance, watch him on his webinars. He talks about how stupid things are. It's really quite funny. But Ivan essentially came out with this idea that, hello vendors, SDN is not netcomp. That is not what SDN is. You can't just simply take and wrap your existing architectures in netcomp packages and start sending XML messages all over the place and call that SDN. That's not what SDN is about. Netcomp is, great question. Netcomp. So netcomp was a attempt by the IETF to standardize programmably, or sorry, I've been up since 6 this morning. Pragmatically define how you interface with network elements. It effectively is taking it's passing messages over XML, specifically over XML RPC. I hope no one here wants to still do that. If you do, okay, that's fine. But I think that networks have evolved, operating systems have evolved to a point where netconf just doesn't make sense anymore. The problem is you couldn't get all the networking vendors to agree. Well, what's an interface? Well, your interface is my port. What's a VLAN? Well, I call it an SVI. Well, I call it a VLAN. I call it a sub-interface. It just didn't work. But many vendors try to define SDN in this way, and they, what they're doing, of course, is they're trying to establish a point of reference around SDN, something that they can put in easily, and hope this whole SDN thing blows away, right? That's kind of what they're doing. Okay. Nor is SDN OpenFlow. This is probably the biggest conversation I get into folks with, whether it's customers, whether it's folks at events, whether it's folks at meetups. Does everyone know what OpenFlow is? Excellent. Okay. OpenFlow is a protocol that was produced by a few guys over at Stanford. I probably shouldn't say that too loudly here. Thinking they knew it, the way to do the way to take next generation networks. OpenFlow is really just think of it as a TCAM programming protocol. It's exactly what it is.
You need to explain TCAM.
All right, excellent. TCAM. A networking device. In a networking device, we have a series of tables that show up in every networking device. And those tables are what we use to determine if a packet comes in port A, what port do I send it out? Typically, it's comprised of things like your MAC address. Potentially could be an IP address. Could be source destination ports. Information of how we move flows in and out of the box. How networks basically work. OpenFlow, though, was a way to say, instead of having all of these operational protocols in the world, spanning tree or OSPF or BGP, that I had to go pay some networking guy way much more money than I should have to put in a system that's way more complex than I'm ever going to really need to run, right? OpenFlow said, well, we can have a centralized repository make all of the decisions, right? If I know that this laptop needs to talk to that laptop, I know what his two addresses are, I can have some centralized system, right, make that decision and push that information into the networking device. So you have no longer do you have intelligence running on the network device. It literally is just a box that moves data in and out, in and out.
So the acronym Content Addressable Memory, TCAM, what's the...
Tertiary Content Addressable Memory is what it stands for.
Why is it so special?
So TCAM, what makes TCAM so special, for lack of a better term, is it's super, super fast, right? So that networking devices, right, can program entries into TCAM a lot faster than we can program into RAM. And by doing so, we're able to keep up with flows that are running on the network in real time.
At multi-gigabit speeds.
At multi-gigabit speeds. Okay? So OpenFlow was this attempt to say, I don't need intelligence on my device anymore. Right? I can have this centralized thing that's going to push all of my information out to the network and just let the network move things in and out. Yeah.
So a slide or two back, you talked about separating the control plane from the data plane.
That's right.
And it seems like OpenFlow is exactly that you put the control plane where you talk about protocols and where you want things to go. And the data plane is all it has to do is decide when the packet comes in here, where should I send it out? It seems like it's exactly the same. You're talking about the same thing here, so why are you
You're absolutely
talking
right.
about OpenFlow?
You're absolutely right. And,
It's like the purest expression.
So let me elaborate on that because that's a great point. So let me talk about the issue with OpenFlow first. So OpenFlow fundamentally works, and it's a great way to do this. It's a great solution. But there's a particular flaw with OpenFlow when you start considering the fact that I've got effectively one centralized brain for my entire infrastructure that makes all routing decisions, right? So that fundamental issue is that he cannot keep up with the speed at which networks are running today.
Well, they don't have to keep up with network speed. They have to keep up with the change in the network speed.
No, they need to keep up with the network speed because, so here's how fundamentally OpenFlow would work, right? If I want to go to www.google.com, right, I'm going to do my DNS lookup. I'm going to get an IP address. That IP address is going to resolve to a MAC address. OpenFlow has to be able to program every box in the path between me and that end system if I was running end-to-end OpenFlow. So let me make a more realistic example. Let's say we're in the data center. Okay? So in the data center, I've got my database nodes running, and I've got my middleware node running. And every time I need to establish a new communications channel between the two, OpenFlow has to program every box in between the two. So if I'm sending up and tearing down a lot of sessions, OpenFlow can't react fast enough. It can't program the network fast enough. And that's where the issue comes in. Now we start to see application timeouts. We see applications that can't run at gigabit line rate speeds anymore. So the concept of OpenFlow is fantastic. It's the implementation that's lacking
Today.
Does that help to clarify, or is there still a question? Okay.
You might have a diagram, a few diagrams.
Yeah, I think I do on OpenFlow here.
Okay.
So getting back to SDN, right? So along comes Quantum. Well, Quantum, we're getting a whole lot closer now. Now we're getting to extracting away the network resources in such a way that we can program the network. Now let's ignore for a minute how we do it. Whether it's OpenFlow, whether it's some other networking technology, Quantum has the capability now to look at resources and build flows based on that resource information, right? Specifically, VLANs, IP addresses, NICs. The thing that Quantum is struggling with is twofold. The first thing Quantum struggles with is the fact that it doesn't operate outside of the hypervisor today, right? It's the first thing it struggles with. there's a lot of infrastructure still sitting in data centers, whether it's legacy infrastructure that we need to attach to, or it's new infrastructure that we're building that exists outside of that hypervisor. The second issue that Quantum is really struggling from today is the fact that it's one and only plugin. And I hope we all know that, right? The struggle with Quantum, and it was true in Nova as well, I can only have one base network system. I cannot have anything else because Quantum can't deal with it. And that's a fundamental problem. In fact, some would say a fundamental flaw with Quantum today.
So just to, again, recap, is the subject of the talk is hype versus reality. So we're not trying to put any technology down. We're just trying to say, here's the state of things today versus maybe some marketware or press releases you might read or hype. So we're trying to position the hype versus the reality.
When you say it deals with this one network plugin, what do you mean?
So in Quantum today, when you put a Quantum server up, when you put up the Quantum controller, you specify what plugin it's going to use to talk to the networking devices, right? And you get one. That's it.
But to be fair, a plugin in Quantum is...
There's multiple plugins
Yeah.
that
Sorry.
we use, right?
No, but the
It's-
point is-
there's multiple plugins that we can use. It's just a matter of using.
Correct. You have to choose one, though, is the
Which
problem.
is normal.
You want to describe the difference between plugin and driver.
Right, okay.
So that separation is starting to happen.
It's starting to happen, yeah. So
And just to address your single node,
Mhm.
well, we have that same problem across the board. But it's
Agreed.
a web service, right? So we're building a web application that's controlling our network. So we apply the same techniques of high availability that we would for the other systems in the OpenStack infrastructure. So you use clustering, you know, whatever mechanism to have failover availability of that resource.
true enough. The difference being, though, is that your environments in the other pieces of the OpenStack architecture are all fairly self-contained. You're not having to really deal with anything outside of the OpenStack framework in those environments.
That's not true, because in every case, if I want to provide availability at any API layer, then I actually have to run let's say a Linux HA cluster and run those on top. So now that's two separate environments, right? Like that's a whole other separate technology space outside OpenStack, a whole other skill set. You know, managing that HA infrastructure to provide the services to enable the OpenStack infrastructure. You know what I mean? And that's all we're doing.
Fair enough. Fair enough. Okay. I understand. Okay. All right. Fair enough. That makes sense. I understand what you're saying. Yes. So that's true. That's true.
Wait, so plugin versus driver.
Thank you. Plugin versus driver. So you know, one of the struggles with Quantum today, or in fact it was actually back in the Nova days, right, is, you know, I think a lot of what Quantum is classifying as a plugin is really, let me rephrase that. Let me try this a different way. The Quantum driver is really what's responsible for talking to the networking infrastructure, right? That's what's actually going to make the exact calls into the box. Now, those calls could be native into the box themselves. They could be to another controller that's going to go out and configure the hardware. For instance, it could be an OpenFlow controller in this particular case. It could be an OVS controller of some sort that's actually controlling multiple instances of OVS running. But a plugin actually is what is dictating to you which of those systems you can use, right? A plugin simply is stating either this OpenStack Quantum controller is going to control OVS, or it's going to control Nexus 1V, or Nicira NVP, right?
Well,
Or
not
Hyper-V.
not
I'm sorry?
thinking
Or
about it.
Hyper-V.
Or Hyper-V.
It's also responsible to determine what would be the, at the end of it, Quantum tries to create virtual networks.
Correct. Correct.
Out of presumably a very large physical network.
That's right.
essentially some network.
Defined by the plugin. Yes.
And the plugin basically determines what's the technology that
That's
you're
right.
going to use. Are you going to use VLANs? Are you going to use tunnels? Are you going to use
NVGRE.
whatever?
NVGRE.
Yeah. So that's effectively the choice of plugin. The fact that there's one plugin is not completely unreasonable, because you probably don't want to mix too many of those technology in the same network.
So here's, and I think that's where the fundamental misunderstanding between data center networks and OpenStack architecture exists today. Is that if you look at how most customers have deployed their data center infrastructures, they, for very, well, you could say good or bad reasons, right? They don't standardize on one type of architecture for doing that, right? They create layered architectures at the networking layer. That came out funny. They create layered technologies at the network layer in order to produce a data center network. And I think that's where the flaw is. So,
accept that for now.
okay, so let's you know, what is software-defined networking, or at least how I look at software-defined networking, right? Truth be told, without getting into any real specifics here about what products these are, because they're really immaterial, software-defined networking, to me, is really, it's two things. It's northbound APIs and it's southbound APIs, and it's some type of mediation system that sits between them, okay? So from a northbound perspective, let me actually switch that, starting from a southbound perspective. Southbound APIs are simply those APIs that allow me to talk to, extract telemetry data, and more importantly, program the network. Of which the best example out there today is OpenFlow, right? OpenFlow is absolutely a southbound API. Now, it's got scaling issues, no question about it. It's got use case issues, but in its pure sense of the form, right, a southbound API would be OpenFlow. From a northbound perspective, we need to start to expose, through that SDN controller, ways that end user applications can tie into these ecosystems. And I think this is really what the crux of SDN controllers is all about, or SDN in general. The problem here is that we've gone ahead and we've started to run before we can walk, because we're defining all these APIs, but we really haven't figured out what the use cases are behind them yet. So we're developing all this raw functionality in the form of an API that we think makes sense. What we don't know, and what we're finding as we start to put real OpenStack applications together, more so on the public side, is there's a lot of feature functionality missing, especially on the northbound side, which has nothing to do with OpenStack, right? It's where are all these ancillary systems, and how do I get information out of them?
Wait, I'm confused. Where's Quantum? What
So
part does Quantum?
Yeah, so Quantum is going to be here at the orchestration layer. On this diagram, it's an SDN application.
So the northbound API is the Quantum API?
Correct. That's correct. That's absolutely correct. But for an SDN controller to be effective, I need information from other sources that Quantum doesn't have access to.
Like what?
So, for example, one of the areas that Quantum has no visibility into would be, say, that's a bad example. The one I was thinking is billing, but that's coming now.
Yes.
So that's a bad example. One of the areas that Quantum has zero visibility to that is absolutely necessary for programming the SDN control layer is how do I interact with those networking components that are north of the OpenStack ecosystem.
You have provider networks now, thanks to Robert, who's not here. Robert Kokura from Red Hat has been one of the guys working on Quantum provider networks. So it basically lets you,
Yeah, go ahead.
Provider networks, it's a feature of Quantum added in Folsom that basically lets you say, I have stuff on my network that you can't control, but you can connect to.
Right, right. So the issue is you can't turn those things up on demand, right?
But that's, by definition, won't be the case, because that's part of your, not by definition of this feature, to be fair, is those are physical instances that you have.
Right.
You will not turn them on by demand because they're physical.
So
they're not part of the virtual.
So when we get into so where that starts to manifest itself as a problem, though, is when we get into network virtualization technologies. NVGRE is a great example of this, right? I can't do NVGRE without having some other external system talking to my SDN controller. Quantum alone can't give me enough functionality.
Not familiar with that protocol.
So
it's just another. It's sort of like VXLAN.
I'm going to do a VXLAN. I'm going to go through VXLAN here in a bit.
You know, competing
Yep.
apples and oranges.
Yeah. So I'm going to actually show a VXLAN in your slide and field. So
That's it. It's not more intelligent.
okay. Sorry, I lost my thought here for a second. Okay. So northbound and southbound APIs, absolutely necessity for software-defined networking. The problem is, what are the use cases behind it, right? And that's what we're struggling to find right now. I don't think anyone debates the fact that they're out there. I think we all know they're out there. I think the issue is twofold. One, how do we define them? And two, how do we get started with them, for lack of a better term, right? You know, the issue being is that a lot of these use cases, while we might be able to start to define them, getting started with them is proving to be problematic because they're very resource intensive networks to really kind of get going with some of these use cases. And I think that's where we're struggling on the northbound API side. On the right-hand side, I just kind of want to lay out the layers here of a software-defined network, kind of as I see it, or as I've seen it working with other customers and with folks in the industry. It really starts at the compute and storage layer, and I think that's well understood with this group. If it's not, tell me. The next layer up is the network layer, and when I talk about the network layer, I'm actually talking northbound of certainly of the hypervisor, and really northbound of your top of rack switch, right? How do we build a network infrastructure that will scale to the demands of OpenStack, while at the same time being able to conform to the necessities of the SDN controller, along with all of the use cases defined in the northbound APIs. The SDN controller itself, again, kind of the centralized brain, but the centralized brain in terms of what it's providing to the entire, attaching the orchestration layer to the network layer. And I'll go through a very specific example of this here in a slide or two.
Wait, so you made a couple of statements that
sure.
Well, you elaborate on. You said that current northbound APIs are lacking in looking for use cases.
Correct.
Can you give me some examples?
I'll give you a real good one because I know it really well. Is the Cisco 1PK northbound API. The problem with that API is it does a great job. It's a fantastic API. That
would be a south API, right?
No, it's both the north. One is both the north and a south API.
Okay.
It does have direct ties to the hardware, but it also has northbound for inclusion into orchestration, billing, accounting, turn up, right on through the list.
I guess I misasked my question because I don't want to learn about Cisco.
Yeah, nor do I want to teach it to you.
If Quantum is the SDN controller in question, and we look at its northbound API,
yep.
Are you, the way I interpreted what you said is that it's lacking in lots of ways, which it still is, but it's been, yeah. I'm just wondering if you have any examples of where Quantum is lacking painfully.
Painfully, I do, and it's how you build network virtualization solutions utilizing kind of what we just touched on, VXLAN, NVGRE, items of that nature. And I actually have an example of, I'm going to go through this here in just a moment.
Okay.
So, let me hold on to that. Yeah.
So what is an example of a use case? Is it a business function or a provider that is hosting services when they get orders for a new application to be rolled out, they automatically provision resources for that or something? I mean, what are we trying to do?
Yes.
Here?
Use case, maybe it's a bad choice of words, but use case is different things to different people, right? To the business guys, it's the business case, right? To the software guys, it's the requirements doc, if you will, or pieces of the requirements doc, right? To the network guy, the use cases is the messaging flow or the protocol flow being implemented. So it's different things to different folks. What I keep saying use case here, that what I'm looking for is kind of a little bit of all of those things, right? How are we going to take I need to do X, Y, Z and frame it up in the context of putting it onto a network and making it happen. That's what I mean by use case.
No, but if you look at OpenStack, or clouds in general, right? The idea is do everything you can do in your data center without ever having to power on a new piece of hardware when you need to deploy something.
Right.
If I need, one of the features in Quantum coming up is load balancer as a service. Right. I want to load balance an application, I call an API, and presto, I got a load balancer.
I got a load balancer,
right?
Yeah.
But so to generalize it, never power up another machine as a user of the application, as the user deploying the application.
Yeah. So why go through this SDN discussion? What are the real benefits of SDN? Well, the benefits of SDN really come in a lot of different ways. But, without going through this whole list of things, and I think we really just kind of touched on, the benefits of the SDN are really, for the first time, being able to build and deploy a physical infrastructure once and be done with it. Expand that physical infrastructure as needed for capacity reasons only, not because I have a new application I want to deploy on my network. Right? It's the ability to say to my customers, I don't necessarily care to a certain extent what you want to do. Right? Here is a bunch of raw power. I'm going to charge you in some kind of billing mechanism to use that raw power. Go crazy with it. Right? That's where we want to get to, and that's what SDN in conjunction with things like OpenStack will ultimately provide. The challenge here, though, is twofold. And again, I won't go through all of this, but the challenge really is, the biggest challenge is around SDN hype, right? Everybody's out there talking about SDN. And it's tough to sort through what is SDN, what is not SDN. I'm going to provide you with a thought around what I think SDN is, and how I quantify SDN in coming up. You may choose to use that, you may choose to ignore it and come up with your own. But I think it at least gets the discussion out there and it gets talking so that we as an industry, if you will, can come to some common definitions and common terms of what we mean by SDN. More importantly, and this is the one that rings very true to me, is SDN can't be about lock-in. It's got to be done in open communities, in projects that facilitate the use of tools that we all have access to, that we all work with, and that we all can have, if we want, at some degree or some level, a say in how it defines and how it ultimately is built and comes together, right? The old days, going back to my previous days of we working on the S390s, right? Those days are done. We got to get out of those days because I think we've proven that when we open up, it really does facilitate and foster innovation.
I have a question.
Yep.
So I'm reading down this list here.
Yes.
And all the benefits, except for the innovation piece, seem to be around business drivers.
Correct.
And the challenges are all technical challenges.
Correct. That's absolutely true. So let me answer there. Let me approach that from the backside, right? I think that SDN conceptually, if you look at everything we're doing here, SDN has been around for a very long time. This is the first time we're calling it SDN, if you will, right? There's nothing new here. What is new is what we're actually using now in data center networks, right? That is what's new. And whenever we have something that's new, there's going to be technical challenges with it, right? So that's why I think you see the challenges are mostly sitting right now as technical issues. The benefits, like any other architecture, the benefits are really all business driven. If I can't make money doing it, there's not a big chance it's going to see widespread adoption. Right? The CloudStack guys will tell you, if you talk to them, especially the eucalyptus guys, they'll really tell you that. The bottom line is we've got to be able to transform it into something that I can actually make money in.
Well, that's true, but I think there is some real benefits because why is SDN becoming popular? I mean, absolutely. I set up a router on my Sunbox 15 years ago.
Sure.
Right?
Sure.
It's trivial. You stick a second card in,
and you got routing. Look at that.
IP packet forwarding, and you're done.
Agreed.
Right? But the issue that why I see its benefit is because you have physical boxes with 40 OSs, VMs. So you have populated with these virtual things, and there's a disconnect between using a physical network for a bunch of virtual systems.
Yep.
So it gives you a lot more flexibility. That's a technical reason for revisiting it.
True, but we're visiting it in a different way, and at least I see it as visiting in a different way. And that different way is we're trying to pull, especially on the network side, we're trying to get those guys out of their ivory towers. Come play with us in this environment, right? Stop telling me I can only give you one VLAN because that's all I can afford to give you from a resource.
496. 4,096.
Technically, I can give you 4,096.
Yeah, which is a problem, right?
Right, absolutely, it's a huge problem.
It is, especially when you get into the carrier space and you're having these people who want to set up
absolutely
clouds on top of their
it's a huge issue. It's a huge issue, and
this is not a scalable solution, which is why we're revisiting SDN.
Absolutely, totally agree. And But I think that we've got to get those environments more ingrained in these ecosystems, because it's the only way it's going to work.
Well, then we're back to the bigger issue, which is we have to stop practicing enterprise computing, right?
Excellent.
And evolve our workloads to the point where we get, the benefits and can achieve, this level of automation.
So let me ask the most logical follow-up question: how do we get there?
So
I've got a thought.
You have to start building it from the ground
You have to start building open systems from the ground up, right? Stop pretending like we're building networking devices on hardware and software that you don't understand because you came from the IT world. Yeah.
You can't mediate the hard bottleneck of 4096 VLANs with SDN. SDN lets you provision, but
Agreed.
to get around the VLAN, you have VXLAN and
Yep.
other topologies and entirely different protocols.
That's right.
So this, everybody, just jumping on that SDN actually solves that problem. That is still a protocol problem.
Agreed.
You got to get away from VLAN in general or layer 2 in general. And just
We could talk.
In general, that's the whole issue.
Well,
why is the internet, on layer 3? Well, duh.
Well, I mean, we could talk for a very long time about.
You can without the hard bound. You can do encapsulation on layer 3 and layer 2, but
The one thing you forget
people should
though
not
is
say that.
layer 2 is
get
always
away.
our CPE, man. Right?
Yeah, but
Layer 2 is always going to plug us in somewhere, and it's always going to be
Yeah,
different
yeah.
depending upon where we're plugging in. So we
Don't-
can
don't
encapsulate
say
this.
SDN
We're
gets
always
away
going to
from
have to
that
encapsulate that
part of
part.
it.
Well, and the other issue here too. Let's bring it back to let's take it right to reality. I mean, we have the same problem at the IP layer right now, trying to get onto IPv6. For heaven's sakes. The point being is that there's a significant amount of infrastructure out there that you can't change overnight, right? We've got to have transition technology, otherwise it's just not going to work. I agree wholeheartedly with what you just said, right? We've known how to solve a lot of these problems for a very, very long time. Problem is, it does me no good to solve it if I can't attach to anything else in the world.
Well, and we couldn't solve it affordably. either.
Well, that's
the
another
key.
issue.
The technology and the software infrastructure is now strong enough where we have an ecosystem to support support the tools to be able to build this.
Agreed. Agreed. And that goes back to the idea of, let's get back to building open systems at the network layer as well as everywhere else that we're doing it, right? Let's make these network systems extensible and programmable and open them up so that really smart folks can make use of that resource much like they can make use of a compute resource, much like they can make use of a storage resource. And start looking at it as resource pools instead of, here's this black box that I have to have there if I want to do anything. By the way, I forgot to ask when we started, do we have a stop time? I should have asked that.
I'd say we'd want to wrap up the slides in another 45 minutes.
Okay. I should have asked that question at the onset, but it's always good to know. So I think, this really ties together everything we're talking about right now. And this is a great quote by Boris. And what he's talking about here is that in order for OpenStack to be successful, in order for SDN to be successful, the network has to become more elastic, right? It's got to become programmable. It's got to be an environment that fosters innovation and creativity at the networking layer. And that's what we're going to try and do. Before I get there, I want to touch briefly on the legacy network data center and why we've got to have these technology transitions in order to help us get there. Legacy data centers, the data centers we're trying to put OpenStack into right now, were really built to handle north-south traffic. The problem with them is that they did a great job making sure that traffic could move in and out of the data center. What they do a really bad job is figuring out how to move data east and west in your data center, how to move from rack to rack to rack to rack. Now that was easy back 15 years ago because the compute infrastructures were all confined to 1 or 2 racks and they were really looking to go northbound anyway, right? In today's world, that's no longer true, and we're really still suffering from this type of a legacy data center architecture.
But that applies in the ISP space. I mean, because the enterprise space, it was more east-west because they were doing a lot of integrated, systems for talking to each other.
I would contend that your large enterprises suffer from this problem too.
Yeah, maybe now in an internet age, but where that's coming from, think of the dawn of like directory services and all that stuff.
Okay, all right, yes.
Networking, your centralized user
Absolutely.
management, all that, how much
Active
traffic burden that
Directory,
put on your network.
Exchange.
Yeah,
All these integrated applications
Yeah.
that are now talking across boundaries to each other.
I think, but those applications, and you might even be able to, you might be more authoritative than me on this, but a lot of those applications weren't pushing at the speeds we needed. They weren't pushing, 10 gig to their limits.
No, they weren't.
Right,
They
so-
were all-
we also didn't have 10 gig.
Yeah, this is,
Well, okay.
yeah, this is 100 gig.
Yeah.
This is 100 meg and 1 gig.
Right, so
That's-
we were able to
that was
mask
the
it
state- Yeah, that was the
effectively.
state of the art.
Right. We can overbuild the data center and mask those problems.
Yes.
Well,
That's exactly
especially now with Hadoop, east-west, multiple racks scale out with Hadoop, virtualization, search, analytics. That's majorly
Yeah,
east-west.
that's major east-west.
And that's what we have today. So
Absolutely.
that's where the new east-west.
The new east-west?
The new
Yeah.
So it's beyond just, you brought up the Hadoop. So the concept of full base section bandwidth,
Mhm.
that's relatively new in network design, or relatively new.
Oh,
in
absolutely.
design.
Absolutely.
Right. So, because to bring it back to OpenStack, if a customer happens to have a bunch of VMs clustered, scheduled across multiple racks,
Mhm.
he still expects a decent network traffic. You still expect any whole.
Well, and to be quite honest, if this infrastructure is provided by a provider, I'm expecting them to live up to some SLA. Guaranteed big times between my VMs, because that's where where we're trying to go.
Absolutely.
So somebody more familiar with data centers, the full base section bandwidth is that. I've only seen it.
Depends upon the data center. I mean, ISP data centers are very different than enterprise data centers.
No, enterprise data centers
Yes.
that you brought up.
I can talk about the enterprise data centers. So when you start talking about SOA, and to follow up on Peter's point, massively integrated SOA infrastructures and enterprise data centers, they really rely on east-west quite a bit. So you have entire authentication servers running on racks and racks and racks, custom built just for that. And yes, SLAs on the application layer are extremely relevant.
Well, transaction
So,
times
absolutely.
Great.
That's huge.
And in scale-out infrastructure, especially scale-out architectures for on the software side, they're extremely temperamental to SLAs. So, what you would consider just to be a function of latency, any transient error, shows up as a resource error because the application just can't handle it. You can't tweak your application to handle it.
Especially if we look at the key markets in this area, we're talking finance, who a lot
Oh,
of their
yeah,
applications are
absolutely.
going to be real time, right? They're going to be late adopters to this. There's
No.
components of OpenStack that they could probably benefit from that aren't quite there yet, right? For even those workloads, but those are going to be services that get built into the infrastructure versus using this infrastructure to build those services on top of, unless they change how they architect those applications.
I couldn't agree more.
You know what I mean? And that's where we're getting, sort of getting to both from the sort of inside the business as well as the core business apps.
Yeah, genomics is another one. Any of the pharmaceuticals are doing massively parallel stuff.
Oh, absolutely. Oh, yeah. In biotech, I mean, there is. I happen to live down in Raleigh, home to a couple of small biotech companies, and I mean, they really, I don't know if you guys are familiar with quintiles, but it's really not important who they are, but they have some real scaling issues moving traffic east-west because of their a lot of their applications being massively distributed. I mean, on just absolute scales we have not seen before.
And to that point too, when you think of simple things like host configuration, we're not integrating the hosts into the network as tightly. A lot of those are using older techniques, and these are things that SDN will help, but it's and I don't we're talking about managing that host interface to the cloud. So basically, we want to take that and just add it as like a circuit.
Yep.
Where we're now just integrating everything as circuits, and then whatever happens on top, we don't really care.
Yep, and every network guy in the world's going to fall over dead when you ask him to do that.
Well, no, I have to be honest. I've been doing it a lot recently, as well as in a prior lifetime. It's a lot of work. It is
I
a
agree.
lot of work. But once you get there, like you said, you set it up once.
That's right.
You don't have to care about it anymore.
That's right.
And it just does it.
Now you scale for capacity instead
Yes.
of for application.
And that model that you mentioned from finance through HPC, through genomics, continues as the speed and the capabilities. There's really, from a perspective of talking to folks that are looking forward and what they're trying to do today, there's not a sector that it doesn't touch. Oil and gas, the seismic information that comes on, and the calculations needed to decide where you put a lease on land. That's the same model as you see in risk analysis in the financial services sector. It's also the same model that you see in insurance.
Mm-hmm.
Right? And that's getting more so with telemetrics. Right? The sheer amount of unstructured data that's coming in from a little device, a snapshot device that you put into your car, that has to be sorted through. The amount of traffic that is now moving to that east-west model and calculated on is truly across the board. It's where we used to be able to say it's high-frequency trading, it's algorithmic trading, it's HPC, it's pharmaceuticals. It's not that any longer. It's now the brains of every major enterprise across the world.
Now think as we start moving to ARM, right?
Oh.
Where you want to talk about where, to me, SDN really becomes important is when you start, as you start increasing your hardware density, through technologies like ARM, right? Because your infrastructure density is just going to exponentially increase.
You start talking to big mobility providers, they're like, oh crap, I don't want to be around when this hits.
Right, but from a workload perspective, that's going to me going to be a great area for growth.
Yep.
In terms of application workloads, for taking advantage of some of these heavily distributed data sets and stuff.
Totally agree. So, north-south data centers really kind of went wrong somewhere. And we really needed to get into an environment that allows data centers to, as we talked about, start scaling east and west, right? Kind of already touched on this, but I mean, that was a perfect lead into what this is trying to say. North-south data patterns are not how we should be building data centers today, and it's not how we should be architecting SDN solutions. We need to architect SDN solutions to provide the maximum growth potential for east-west growth, so I can simply augment capacity and not have to add equipment, add resources, add infrastructure just to simply support a new application. So with that, I want to walk you through what I call is 4 pillars of software-defined networking. Make sure I said that right. So really when I look at SDN, I really kind of, and again, I'm approaching this from the network perspective, so kind of put that context in mind for just a moment as I work through these next slides. But I really want to look at this from 4 different angles. One, we've got to have a way into the network, right? We've got to have a way to manage these networks. We've got to have a way to get telemetry out of these networks, and we have to have a way to orchestrate these networks, right? 2, we have to bring in a combined L2, L3 control plane that works together. And I'll talk about that in a little bit more depth in another slide here too. 3, we've got to stop wasting links in the data center. Anyone who's ever turned up a spanning tree network knows what I'm talking about here. That is, most data centers today, especially those that are north-south based, are really running at about 50% capacity. We got to get that other 50% into the mix so that we can get to the cost-effective nature of running these networks that really allow us to achieve SDN in a way that makes sense, in a way that we can make money at, and in a way that scales long term. Last but not least is then how do we use all of this to create network-wide virtualization so we get out of the, I can only give you one VLAN, Mr. Customer, right? We need to get away from that. So, where's the innovation as we talk about single point of management? And this is probably the single biggest facet I see for software-defined network when I'm out talking with really anyone. And I always ask my crowds, right, quick, can you think of 5 things that have been innovated as it relates to network operations in the last 10 years?
4.
I mean, if you can come up with 2 or 3, I'm impressed.
Auto-config.
Auto-config. We go all the way back to the days of SLARP with that one.
They came really late to networking.
VPC from Cisco.
How is VPC innovation?
Active still with spanning tree.
But is that innovating single point of management?
Single point of what?
Management.
I didn't see that little.
Yeah. Single point of management. So I'm thinking operations here. right?
Auto provisioning is.
Auto provisioning is one I hadn't thought about before. That's a good one. So the point being is that network operations have been. I'm sorry.
There was all kinds of MPLS related stuff, but CR, traffic engineering with MPLS, CR,
No MPLS.
So I would contend that that's not real innovation.
No, because it's been around forever.
Absolutely, absolutely.
The only thing new with MPLS is we're using it.
People are getting, but it's going away too.
Well, right.
MPLS is repackaged ATM, which is repackaged X.25. I'll go on all day. So as it relates to the next thing is and I touched on this a little bit earlier, and I'm going to expand upon it now. We've got to get these networking folks, whether it's the vendor, whether it's the network engineer, whoever it is, get them off the damn CLI and get them into open systems, right? Realize that you are now part of something much bigger, and you've got to get out of your ivory towers, you've got to get out of your walled gardens, come to the table, come to the game, come to the sandbox, let's play together. And we do that by really starting to open things up at the network layer, right? Let's expose that information, both from an operations standpoint and from an engineering standpoint, right? We really want to open this thing up, because when we do, we can really start to innovate in areas around operations and areas around engineering. We can start to produce data sets that you can use as ingest into your application environments to make smarter decisions about how applications deploy themselves, how they run, how they operate. This is one of my favorite ones. Most folks don't know today that still the de facto standard for getting telemetry data out of a network is ASN.1. Does anyone even know what ASN.1 is?
Yeah, and why is that a problem? It's like saying, oh, well, the real problem with IP is that it's big endian. Who cares? It's under the covers. All the tools talk. Who cares if they talk ASN.1 or XML or JSON?
Because you can't expand on it easily, right? I cannot build a network operating system today and give it to my customer, and that customer wants to expand on an ASN1 data set from that box.
Hey, it's been working for 40 years.
Absolutely, it's been working great for 40 years.
So is X25.
So is X.25. So I'm not saying ASN1 is bad, I'm just saying it's time to move on from ASN1. That's all I'm advocating here. Visibility into the network, right? Let's stop hiding what the network's doing and let's really open it up. And maybe the last bullet is probably the biggest one. We need to start to move to event-driven architectures. Right? We need to start moving to network-based architectures that are triggering events in real time so that we can respond to them. Right? Let's eliminate all the dead black polling windows. Oh, I can't see what's going on for the next 5 minutes because I wait for my next polling cycle. Right? Networks are running too fast. There's too much at stake. We've got to be able to react in real time to events going on in the network. I can't wait till the network's dropping packets to start doing something. I need to do it sooner. So, extensibility and programmability. It's what the network's all about, right? And this is the question I get all the time. When you say extensibility, oh yeah, Perl, Tickle, expect. Yeah, I got my libraries. Everyone's got their libraries on the networking layer, right? Hell, I got libraries that are on the coffee machine in the break room at the office. This is not what I mean by extensibility. What I mean by extensibility is let's open up the network so that we can take advantage of everything that's out there. Yeah, I got customers. I can tell you people today that want to do job on the network layer device.
Yeah, then your security and your compliance people.
Different discussion. That's next week's topic. Different discussion. I know of a company right now that's trying to port mono onto a network switch. Why, I don't know, but that's another story. But they told that to me, and I was like, wow, you got guts.
Well, it makes sense. Gives them a custom, easy interface that has a huge developer community. Right?
Yeah, so most of their business critical apps are written in C#, and that's why. That's why I want to move mono.
You're talking about extensibility technologies and knocking ASN1, which is the binary encoding for SNMP, whoever didn't know. What kind of extensibility you're looking for, regardless of what technology you...
So let me throw out an idea here. What if I could deploy a network box today, or you could deploy a network box today in your network environment. And in that network box, I want to I don't like the BGP implementation. Just don't like it. It's based on Gate D. It's old. It's got bugs. Everyone knows about it. No one wants to fix it. I don't like it. I want to fix those problems. I could, when I mean extensibility, I mean I could replace that BGP daemon with my own BGP daemon.